Okay, we're gonna get started because I have 20 minutes to tell you everything you need to about how to choose the right Azure PaaS offering for your SQL Server workload. No problem with 20 minutes, right? This is a fast focused session, so I can talk fast. First off, SQL Server 2025 is GA as of today. Also, Fabric, SQL database in Fabric. So Fabric did as GA as of today. Now you might be thinking to yourself, okay, this is a PaaS session. What are 2025 and Fabric have anything to do with PaaS? And there's very good reasons because Azure SQL kind of sits right in the middle of on-premise SQL and SQL database in Fabric. In fact, SQL database in Fabric is a SaaS service and actually uses PaaS databases. And SQL Server 2025, of course, runs on the ground. It runs in cloud Azure VMs, but everything that's in both of those products started in Azure PaaS. So if you're working with Azure PaaS, you are working with a familiar environment, right? Same T-SQL you know of, where it runs everywhere. Same engine, same tool set. It'll run in Fabric. It'll run in Fabric. It'll run on the ground, run in Azure PaaS. So this is important. And also when it comes to, when we talk about migration options, there is a tag in here for SQL 2025 and Azure SQL Catalyst. We're going to focus on this middle icon here. And we're going to try to simplify this as much as possible, right, John? I don't want to make any assumptions that anybody knows the difference between VPMs, IaaS, and PaaS or everything. So just a quick level set of everything. Back in my day, when we started running SQL servers on Windows, and you have an operating system, you install this on bare metal. Every time you needed a new version of SQL Server or a new installation of SQL Server, we install Windows, rack a server, and you install SQL Server, and off you go. Now along comes hypervisors, where we can actually take the SQL Server operating system, all the core components of SQL, and the engine, and all the things that you know and love, and we can run them inside our virtual machines. And this was awesome. We had Hyper-V, we had VMware, and then along comes the cloud, right? And in the cloud, now what we can do is actually take all of those things that we're running in an on-prem world. Imagine taking that SQL Server instance that's running in that hypervisor and now move that hypervisor up to the cloud, right? That is SQL Server on virtual machines. That is what we call IaaS. Now, take the operating system piece out of that. And let's just say I need an instance. I need an endpoint and the ability to have some databases on that endpoint. That is actually what we call managed instance. This is where we get into the PaaS territory. Now, if you need to take this one step further, let's abstract away and just say, I just need a database. All I need is a singleton database. I need to put some data into it. I need to read some data out, but I need the same SQL Server engine. I want to be able to use the same T-SQL footprint for everything that I'm doing. That is what we call Azure SQL Database, right? So this is the family of how you can run SQL Server in Azure. And there's a lot of reasons that SQL PaaS is great, right? It feels like it's a SQL instance or a SQL database. It's familiar, but you don't have to manage any hardware or a VM or an OS. You do if you're running SQL in VMs, for example, in the IaaS world. You get to do everything, standing up FCIs, standing up availability groups, managing Windows, managing logins, patching security updates, all that kind of fun stuff. You don't have to do that in the PaaS world. You get continuous innovation. Where we start to get really crazy and complicated is when people start to say, okay, now I need to go to PaaS and I need to decide if I need general purpose or business critical and how many vCores do I need and how much memory do I need and do I need to do this and this and this and this. Let's not get there just yet, okay? Lots of great reasons to like PaaS and what it offers, but it often just, you get this paralysis of analysis when you get down to the details too fast. So let's talk about things in a slightly different perspective. Let's talk about them from the standpoint of migrations and innovations. Now, if you wanted to migrate from on-prem to Azure, simple lift and shift, the easiest thing that you can do is just take your VM wherever it's running on-prem and you can snapshot that VM. You can actually move it over into Azure. And that's easy. That's the fastest way to get into the cloud. A lot of companies do that, right? If you wanted to get out of the world of managing the operating system, patches, security updates, everything else associated with running Windows and managing all of that, you can migrate to managed instance. So managed instance is a great landing solution for migrating apps at scale, still getting that instance-like experience, but taking away the operating system management out from underneath it.
And in terms of innovation, if you wanted to start from scratch, build brand new apps in a cloud-first environment, this is where we generally recommend an Azure SQL database. So you can develop highly scalable, AI-ready applications and still get the SQL engine that you're used to, and all of the other things that come along with that. Now, to help you with these migrations, we have something called Azure Arc, and I'm going to talk about this a little bit more in just a minute. With Azure Arc, it's essentially a service that you can run on premises, and it talks to your databases that are not running in the cloud, wherever they happen to be running, talks to your VMs really. So they could be AWS, it could be GCP, it could be SQL Server on-prem, and it connects those on-premises versions of SQL Server to Azure so that you can have a visibility into your entire real estate of SQL Server in the Azure portal. And this will become important in just a minute when we talk about how do we actually move from SQL on VMs or SQL on-prem to one of these PaaS offerings, right? So the right two we're going to be focusing on for the rest of the session. So there's our delineator, PaaS, and IaaS, okay? Now, given this framing, how do you choose the right target? How do you choose between SQL Database Managed Instance, Azure VMs? Well, we already covered that if you wanted to start from scratch, consider starting with Azure SQL Database as a great starting point. You can scale up and down. You can have as many CPUs as you want, depending on the service tier that you're at. We'll get there in a minute. And you can scale up and down, right? If you need more CPU, you can add more CPU. If you need to drop the CPU, you can drop the CPU. With hyperscale, which is another flavor of Azure SQL database, you can go all the way up to 100 terabyte plus of storage. That limit's actually higher now, it's 150. With managed instance, it's an easy middle ground, right? If you need to migrate and get that instance model, consider managed instance as your target, but it's also a great place to start for innovation because there may be things that are in SQL database that are not part of managed instance. And of course, if you just need that lift and shift, you need the OS level access, you need things like SSRS or AS, or you need a specific version of SQL Server, then stick with Azure or stick with a SQL Server on Azure VMs. This sounds great, right? These are really, this boil it down to really easy choices, but there's a little more than that because the devil's in the details. When it comes down to it, there are certain features that are not available in these different flavors of SQL Server, right? So in Azure VMs or in SQL on-prem, no problem. You get the whole of everything that's built into the box. But as we start to migrate over to the MI world or the DB world, you can see on the long exhaustive list of features, which I won't go over every single one of them, but you can see that there are certain things that are not supported. So consider this as one of those drivers for deciding if DB is the right place for you. For example, if you need cross-database queries, that's a little bit harder in SQL DB. You want to think of SQL DB as just a contained database. It's not impossible, but it does require some extra programmatic things outside of the context of just referencing with four-part naming conventions or three-part naming conventions in T-SQL to just join a couple of tables in different databases together. Right? If your solution on-prem that you're trying to move to Azure, for example, relies on things like temp-DB metadata optimization or relies on certain replication options, then something like a managed instance or a SQL DB may not be quite the right thing for you. So it's not just as simple as if you want to innovate, go to DB. If you want to migrate, you go to MI, right? You may want to innovate, but MI has the feature set that you actually need. So now that I've framed it that way, I want to think about a little bit more in detail about the things that you might consider when you're trying to pick your PaaS offering. And so this is where things start to just go off the rails really quick because you can get really mired down into the details of thinking about things like, what region do I need to be in? What's my service tier? What is a service tier anyways? What's my compute tier? What generation of hardware do I actually need? How many vCores do I actually need, right? Do I need zone redundancy? What's my licensing costs go for? This is where things just go south really quick, honestly, when you're trying to pick your options. So I want to simplify this as much as possible. And let's talk about this in terms first of just SQL database. When SQL Database first came out, there was a real simple purchasing model. It was called the DTU model. It was this blended metric of storage and compute that just scaled linearly. So if you need 100 DTU, it's twice as much as 50 DTU, or 200 DTU is twice as much as 100 DTU. But what we found really quickly is that just doesn't fit every single solution. People don't need that linear scale. Sometimes you need more memory. Sometimes you need more compute. So we introduced this vCore model, which allows you to scale your compute and your storage independently of one another. Now, there is some inherent tie in there between memory and compute. For example, you can only have so much memory associated with one vCore, right? Think one CPU. So if you need really extreme amounts of memory, you might need more vCores, and that's just the simple physics of computers and the actual, when it comes down to it, the actual memory on the chips and on the bus, on the physical hardware that's running in data centers. So if you want ultimate flexibility, transparency, and control over your amount of memory and your storage and your compute, then you'll want to lean towards that vCore model. And we offer vCore models in both SQL database and managed instance. DTU is a SQL database only thing. And then you'll start to think about things like optimizing for cost, because cost is always a factor, right? So we have some additional options, one of which is serverless in SQL database. Imagine being able to just effectively stop your SQL Server instance when nobody is using it. That's essentially what serverless amounts to. You're billed by the second. So if you have really varying workloads that are bursty, where you use the database during certain portions of the day and not others, serverless might be an optimization for you. But I'd like you to think about serverless as more of an optimization, not as a deployment choice up front. The other option is for pre-provisioned, where you just basically say, I need 2 vCores, 4 vCores, 8 vCores, or 128 vCores, and I need them always available, always on, so that whenever I connect to my database, they're there, right? So if you have workloads that have regular, substantial compute utilization, or if you have multiple databases that have bursty usage who are connected to that instance, then a pre-provisioned type of a model is for you. There's also another consideration in Azure SQL Database. A flavor is called hyperscale. You'll hear this term thrown out sometimes. So hyperscale is actually a different architecture under the hood. We only have 8 more minutes at this point, so I'm not going to cover the architecture of it, but there's plenty of public documentation. Essentially, it's still the same SQL Server engine, but we do a lot of fancy things with page servers and compute servers under the hood to be able to allow you to scale your databases all the way up to 150 terabytes, 128 terabytes, or less if you need it, but you can scale all the way up to 128 terabytes. You get things like low latency, you get high throughput, you get read scale support with 30 named replicas if you would like. So you can have named replicas all over the world if you would like. Backups are taken with a different mechanism called snapshot backups. This is an option that you can go to in Azure if your workloads actually fit. You need that scale for that size and that compute capability. Often our recommendation is if you're starting somewhere from scratch and you don't know where to start, hyperscale might be a good choice if Azure SQL Database, that singleton contained database, fits your workload pattern. Hyperscale is not a bad place to consider starting. Some other things that you're going to see as you talk about optimizations for compute, again, afterthoughts to do I need MI or do I need SQL DB? You'll see something called elastic pools, right? So when you go and provision a database, you might say, well, I need a certain amount of compute. And if you go pre-provision, that compute is always available for you. But if you need 10 of those databases, and maybe during the top half of the hour, 5 of those databases are used, and at the bottom half of the hour, the other 5 databases are used, well, your cost is fixed because you are pre-provisioning, they're always available, and you're going to pay no matter what for the length of that hour if the database is used or not. So if you have a bunch of databases that individually are unpredictable in their usage, you could consider pulling them together to share resources in what we call an elastic pool. When you put your databases together in an elastic pool, you're being charged essentially for the max of the peak utilization of any given database at any given time throughout that hour. So your databases that need the compute at the top half of the hour get it when they need it. And then when they're quiet and the other databases need the compute, they get it as well. And you're only being charged for the usage of the elastic pool, right? The combined usage of the databases across that hour, year, month, whatever. So something else to keep in mind when we get to talking about optimizing is an afterthought to, do I need DB or do I need MI, right? So this is as nerdy and as deep as I'm actually going to go in here. Like if you want to take a picture of this slide, great. These slides will be available for everybody afterwards as well. This is why you can get lost in the weeds really quickly, because you're like, wow, I can go down into Gen 5. I have to pick DC. Do I have to pick memory optimized from, right? Do I need, how much space do I need? Do I need this? Do I need memory? Like you can get really lost in the weeds trying to pick this. So I show you this because this is at the point where you've said, I either need MI or I need DB, then you can start to think about, do I need to use general purpose, which is for most workloads that are just budget oriented? Do I need business critical where I have high IO requirements and high uptime requirements? Or do I need hyperscale where I need very large databases and even analytical, like HTAP workloads for analytical purposes, right? And each of these has optimizations under the hood to help with the compute needs and to help you optimize the costs for them. But I don't want you to start here. I want you to go back to the very beginning of what I talked about and say, does MI have the feature set that I need? Does DB have the feature set do I need? Maybe PaaS isn't even the right solution, and IaaS is what you need because the features that are in the box are not available in either MI or in SQLDB. One other note, since we're talking about GA announcements, we also announced a new flavor of Azure SQL Managed Instance. It's called Next Gen General Purpose. You can scale up to 128 cores and up to 870 gigabytes of memory. So that's now available as well today, if you would like to check that out. Okay, I talked already about if you're going to start from scratch, a great place to start, consider SQL database and maybe even the hyperscale service tier, right? What if you're going to take your existing workloads? How do you pick where to land? Well, we already know that certain features are available in either MI or in DB, but how do you actually get there, right? And I mentioned Azure Arc earlier, so I'm going to tie it back to Azure Arc here now, right? So you don't just say, hey, MI sounds like the right place to go, let's land there. Or you don't say, DB sounds like the place to go, let's land there. Had somebody who was moving from on-prem to SQLDB once say, how do I restore my database? Well, there's no native backup and restore support taking your BAK files from an on-prem SQL server to an Azure SQL database. That kind of threw them for a loop. They didn't know that. So those are the kinds of things that you need to think about and plan for when you're migrating. Where I'm going with this is there are a number of different migration entry points. You have the Azure Database Migration Service. You have a new wizard that's in the SSMS. It's a new extension that's been added. There's also the Azure Migrate Service. There's SSMA. If you're bringing heterogeneous workloads like Oracle or other database management platforms into Azure SQL, okay? Let's focus on this Azure Arc for just a second, because how do you pick from all of these things? Well, Azure Arc is actually a great place to start to help you figure out where you need to land for picking the right PaaS database. Because there is now a new feature in Azure Arc, which is a migration experience, a simplified migration experience. So when you connect your on-prem servers or your servers that they're running in another cloud with Azure Arc, not only can you see them in the Azure portal, but you also now get, as of today, generally available, continuous assessment, where we will pull for the features that are being used in your database and the CPU that's being used in your database and other key metrics to help make recommendations for either landing this workload that's being connected to Azure Arc in IaaS or PaaS, and whether managed instance or SQLDB is a good fit for this. So you can grab these slides and you can actually see them. There's a bunch of really interesting things in here, but the key takeaway from this migration experience is that it simplifies the entire experience from both monitoring, measuring your workloads and making these recommendations, and it can help you actually migrate to that target platform of choice using the Azure Migration Services and DMS and all the other things that I showed you on that previous slide where you had 7 different choices or 4 different choices. Now you can use the Azure Arc new capabilities to simplify that down to one single tool that you could use to actually migrate. And there's a migration assessment. So there's a couple screenshots. So I'll let you go through the decks and see these yourself, but there's a migration assessment. You can see what it would look like if this workload landed on MI and what service tier and what compute you might need to pick. What would it look like if you were going to land on IaaS or if you were going to land on SQLDB to help you make that choice. This will also allow you, because you're connected to multiple SQL servers, or if you connect Azure Arc to multiple SQL servers, this will allow you to gauge the impact across all of those connected servers. So you can tell if at scale, whether DB is the better option and if Elastic Pools make sense, or if IaaS or some other like managed instances for you. And we love Copilot. So there actually is some Copilot assistance in this as well. So you can actually ask questions and say, am I the right workload or the right fit for this particular workload, right? So grab the slides. You can get some more information in depth on these. Um, and if you are still not sure, and you're not quite sure if like MI will fit for your workload or if SQL database will fit for your workload, I want to leave you with this. We have free offerings for both. So you can just try it out yourself. There's a Azure SQL database version that's free, and you'll get 100,000 vCore seconds of compute and 32 gigs of storage every month. And there's also a SQL managed instance for free where you get 750 vCore hours of compute and 32 gigs of storage every month. So you can go and try these try before you buy, right? Without having to spend any money. Okay, on the slides, there's a bunch of additional resources, so I'd encourage you to download these. There's a bunch of free Azure training, free Azure SQL training. There's all kinds of things on Data Exposed where you can learn more about this. This was just scratching the surface to make sure you understand the landscape of SQL and Azure and what the key differences are between the different PaaS offerings. And if you have any questions, we have another fast focus session coming right up in now 8 minutes. So I'll actually go outside if you wanted to talk a little bit more. Otherwise, thank you very much.